On a warm winter day in 2005, a wildlife biologist in southern New Mexico stopped to fix a fence on a salt flat. The wind had scraped the surface raw, and there, in the dried mud, was a shape he almost walked past. It looked like a boot print, maybe a ranch hand's, maybe nothing. He kept working, but the shape stayed with him. It nagged at him for years, because the thing pressed into that ground was not a boot, it was a bare human foot, and it had been there since mammoths still walked across that basin. The biologist's name was David Bustos. He had come to White Sands National Monument as a wildlife manager, not an archaeologist. But the salt flats had a habit. After rain, shapes would rise to the surface, prints, outlines, long vanished pathways, and then disappear again when the ground dried. The staff started calling them ghost tracks, visible only when the moisture was right, gone the rest of the time, and gone forever once the wind peeled them away. By 2009, Bustos had taught himself to read the playa like a page. He could pick out mammoth tracks, ground sloth tracks, camel. That year, walking along the edge of what had once been a massive Ice Age lake covering 1,600 square miles, he found what he had suspected for 4 years: human footprints pressed into the same layers as the megafauna. People and mammoths walking the same ground in the same centuries. He had no way of knowing that those prints would end up in Science magazine, drag the United States' oldest origin story into a public fight, and force a generation of researchers to accept that almost everything they had taught about the peopling of the Americas was wrong. Fossil footprints had actually been spotted at White Sands before. Back in the 1930s, a government trapper named Ellis Wright reported giant tracks out on the flats. Nobody paid much attention. They turned out to belong to giant ground sloths, but human prints, that was different. The problem was proving it. Ghost tracks do not sit still for examination. Bustos spent years documenting what he could, photographing prints in the narrow window when they surfaced, watching them crack and blow apart days later. He once said it plainly: "We're losing them." Then, in September 2019, a windstorm ripped across the basin and exposed something no one had seen before. At a low bluff, the team had checked dozens of times. Clear human footprints appeared in the sediment wall, rows of them stacked in layers, one generation pressed on top of another. The site was designated Locality 2. It was roughly the size of half a basketball court, and it held a record that would take the next 6 years to fully defend. A team led by geoscientist Matthew Bennett from Bournemouth University excavated 61 human tracks across 8 separate layers. The prints had extraordinary anatomical detail: heel impressions, arches, individual toe pads, and the people who had made them were not who anyone expected. Most of the track makers were teenagers and children. The dominant age group was roughly 9 to 14 years old. A few adults appeared, but this was overwhelmingly a record of young people working the shore of an ancient lake while the grown-ups did something else nearby. I keep coming back to that detail. Not warriors, not hunters crossing a frozen continent. Children doing chores by a lakeshore, barefoot in the mud. That, more than any number, is the thing that makes this site impossible to look away from. Then came the dates, and the dates broke the model. USGS geologists Jeff Pagati and Kathleen Springer radiocarbon dated seeds of Ruppia serosa, a small aquatic plant, from the sediment layers that sandwich the footprints. The results, published in Science on September 24th, 2021, placed those children on that lakeshore between 21,000 and 23,000 years ago. Not 13,000, not 15,000, 21,000. At that moment, every major textbook in the country agreed on one thing. The first humans in the Americas were the Clovis people, who arrived roughly 13,000 years ago, carrying a distinctive stone spear point. That was the consensus. It had survived decades of challenges. Sites like Meadowcroft in Pennsylvania had been fought over for half a century. And here was a set of bare footprints, not stone tools that could be debated, not charcoal that could be questioned, human feet pressed into mud, dated 10,000 years before Clovis was supposed to exist. Footprints do not get redeposited by water. They do not migrate between layers. They are exactly where someone stood at exactly the moment they stood there. As one researcher put it, it's just screamingly obvious that the tracks are human. The reaction was immediate, and it was brutal. A group of respected scientists, Lauren Davis of Oregon State University, David Madsen, David Rewrote, Charles Oviatt, challenged the dates on a single devastating point. The plant Rupia serosa is aquatic. It does not pull its carbon from the atmosphere. It pulls it from the water, and if that water carried dissolved ancient carbon, old limestone, old rock, the plant would absorb it and appear far older than it actually was. The freshwater reservoir effect. Davis said it directly. If there is old carbon in the groundwater, then you get old ages on plants that are not that old. Their alternative estimate brought the prints down to roughly 13,500 to 15,500 years, still early, but not impossible under the old rules. This is where the story could have stalled, the way Meadowcroft stalled, the way a dozen other pre-Clovis sites stalled, buried under doubt that was technically reasonable. But the White Sands team did something that changed the arithmetic of the argument entirely. They went back and dated the site again using methods that had nothing to do with aquatic seeds. In October 2023, Pagati and Springer published a second study in Science. This time they used two completely independent techniques on the same layers. First, they extracted terrestrial conifer pollen, plants that fix their carbon from the atmosphere, immune to any reservoir effect. Using flow cytometry, they isolated roughly 75,000 individual pollen grains per sample, barely visible to the naked eye, but enough to date. Second, they ran optically stimulated luminescence on quartz grains, measuring how long the sediment had been buried since its last exposure to sunlight. Both methods returned the same answer: the last glacial maximum, 21,000 years. The original seed dates held. Springer said it without hedging. Our new ages, combined with the strong geologic, hydrologic, and stratigraphic evidence, unequivocally support the conclusion that humans were present in North America during the last glacial maximum. And still, a minority pushed back. Rode and colleagues published a critique in 2024 arguing the pollen could have been redeposited from older sediment. The team replied. Rachel and Dello Russo challenged the seed dates again in 2025. The argument narrowed, but it did not close. Then, in June 2025, a team led by Vance Holliday at the University of Arizona added a third line of evidence. They dug new trenches and radiocarbon dated the lakebed mud itself, 26 additional dates, processed by two independent laboratories. The footprint relevant layers came back at 20,700 to 22,400 years. 3 different materials, 3 different methods, 5 different labs, 55 consistent radiocarbon dates. Holliday said it simply: it's a remarkably consistent record. You get to the point where it's really hard to explain all this away. And underneath those numbers is a story that has nothing to do with laboratories. One trackway, documented in 2020, runs for 1.5 kilometers across the ancient lakebed, the longest known human trackway from the late Pleistocene. It records a single adult, probably a woman, carrying a toddler under 2 years old. Her prints widen and slip asymmetrically in the mud under the shifting weight of the child. At intervals, tiny prints appear. She set the child down, adjusted, picked them up again. On the return trip, the prints are narrower, steadier. She came back alone. Between her 2 sets of tracks, a mammoth and a giant ground sloth had crossed her outbound path. She had walked through a world that no longer exists, doing something any parent would recognize. In another area, human footprints were found placed deliberately inside the tracks of giant ground sloths, the sloth turning in defensive circles, other human prints positioned at a safe distance. A coordinated hunt, a community working together against an animal that could kill with a single swipe. And in early 2025, the team published a new finding: linear drag marks running alongside footprints at 5 locations up to 50 meters long. They tested the hypothesis by building replica travois, 2 poles dragged behind a person to haul loads, and pulling them across mudflats in England and Maine. The fossilized marks matched. If confirmed, these are the earliest evidence of human transport technology anywhere in the world, 22,000 years old. The implications land hard. If people were in southern New Mexico 23,000 years ago, they were there during the last glacial maximum, when the Cordilleran and Laurentide ice sheets had merged across Canada and the interior corridor between them was sealed shut. Their ancestors could not have walked through that ice. They had to have come another way: the Pacific coast, the Kelp Highway, skirting the edge of glaciers in boats or on foot along a shoreline that is now 400 feet underwater. Clovis First did not fall because of one site. It fell because the evidence kept arriving from too many directions. Monteverde in Chile, Meadowcroft in Pennsylvania, Chiquihuite Cave in Mexico, but White Sands may be the hardest of all to dismiss because there is no ambiguity in a footprint. You cannot argue that water shaped it. You cannot claim an animal made it. A child pressed a bare foot into wet mud beside a lake, and 23,000 years later, the wind uncovered it just long enough for someone to notice. The ghost tracks are still disappearing. Every season, erosion takes more of them. The team is racing to document what they can before the playa reclaims it. As Bustos once put it, when critics challenge one layer of evidence, if you don't like one layer, okay, that's fine, here's another one. If you don't like that, well, here's another. What stays with me about White Sands is not the number. It is that the oldest firm evidence of humans in the Americas was not left by hunters or warriors, but by children, teenagers carrying loads to the lakeshore, a mother walking through the mud with a toddler on her hip. Their footprints survived because the ground remembered what history forgot. Somewhere on that salt flat under a crust of gypsum, the next trackway is waiting for the next windstorm to pull it to the surface. If stories like this are the reason you are here, hit subscribe, because there is always another layer underneath.